Hey everybody, so my name is Khushbu and today we are going to discuss about linked list. So linked lists are linear data structure where each element is a separate object. Its element its elements are not stored at a contiguous location but they are joined with the help of pointers. For example, we have this grid. Suppose this is our memory. So when we initialize this array, we got this contiguous space marked in green. But in a linked list, we take many elements and join them together. Elements are generally called nodes. For example, we have taken this node A, then B, C, and D, and then we have joined them with pointers. So that's how we create a linked list. So here we are making a node. We are defining its structure. So each node is made up of two items, the data and the reference to the next node. So here we have taken so many nodes and then joined them with the help of pointer. The last node reference to null. The entry point to a linked list is called the head of the list and ending point may be called the tail. But head is not a separate node. Head is just a pointer reference to the first node. And if the list is empty, it will be a null reference. There are many advantages of a linked list. So, as linked list is made up of separate objects, it have dynamic size. So we can add or remove as many nodes as we want. Also, inserting and deleting a element from a linked list is easy. Whereas the only drawback of a linked list is that the random access is not allowed. As if we have the head node, we just know the address of the second node. When we got to the second node, we just know the address of the third node. There is no way that we can directly go to fifth. So let's jump into the implementation of the linked list. So here I have initialized the linked list. I have made two pointers, head and tail, and made them private because we don't want to lose them. Now let's add some nodes to the list. So let's write its function. So in this function add node, what we have done is we have taken a temporary pointer called TMP and allocated it the space required by a new node. Then we have given temp data n the input and temp next null. So we have created the node, we have given the data and we have given it the pointer. If and now we are saying if head is null, then head and tail are temp because if head is null means the R linked list is empty. So it will be our first node. So it's both head and tail. And if it is not, the head is not null. So we have to add it back of the linked list. So we will say give the tail next pointer to TMP. Tail next pointer was till now pointing towards null. So now it will point towards TMP and then tail next will point towards null. So let's write a main function to make our linked list. So here I have made linked list A. So we have made our linked list, and here we have added a node in it. So it will look something like this. So here it is the head and tail both of the list. Now let's add another node to it. So as our linked list is not empty, so this will get added up in the back of our linked list. So now our linked list becomes this, the head is this, and 7 becomes its tail. How can we display our linked list? Or we can say, how can we iterate over the whole linked list? So that is very easy. So let's write its function. Let's call it display. So for the display function, what we have done is, we have said, so we have taken a temporary pointer temp and then given it the head value, and then basically we have 3 steps to do. We have to check if our node is not null, then we have to print its data, and then we have to go to the next one. So we are doing the same. We are going over the while loop. We are saying if it is not equal to null, print data, and otherwise go to the next. So in this list we got to the head, that is temp. So it is not null, so we write 4. Then we go to the next pointer, that is 7. It is not null, so we write 7. And then we check the next pointer and it is null, so that ends our while loop. So now if we say we have to add a node to the list, but not in the end, but somewhere in the middle with the given index. So let's try to write function for that also. Let's call it add after. So what is value? Value is the value that we want to insert, and A is the node after which we want to insert that new value. So let's see. So let's try to add a new node. So let's add 3 after 4. So for adding 3 after 4, we will have to make a new node and give it the value 3. So as we have done, P next is equal to A next. So we have to give its next pointer to the previous next pointer. So we will do this. Then we will give a next pointer the value p. So we will change this pointer, and then that's how we insert this in our linked list. So for example, if now we want to insert 2 before 3, so what we will do, so we create a new node, we give it a next pointer, we change the old pointer, and we inserted it. So that's how it works. So we have inserted the values in the tail of the list. We have inserted the value in the middle of the list. So let's insert the values at the beginning of the list, that is at the head of the list. Let's call it add front. We are inputting the integer we want to add. So firstly, I am inputting the integer n. That's the value I want to input in the front of the list. Then we are creating the same temporary pointer and making it a new node. Then giving it the value n. Give temp.next the value of previous head. And then we are changing the value of head to the temp. So let's try to visualize it. So let's add 8 to the head of the list. So firstly, we created a new node, then give its pointer to the previous head, and then give head pointer to this node. And that's how it gets inserted in our list. So we have made a temporary list. We have added the elements in the front, middle, and back. We have iterated all over the list. So, so let's now write the function to delete a node from the list. So when we delete any node from the linked list, so what we do is we connect its previous node to its next node. So it basically get invisible from the memory. It is there in the memory, but we don't have its address. So B will be the node that will be previous to the node that we want to delete. So we have done the same task as the previous one. We have so here what we have done is we have created the same temporary pointer, then so we have created a temporary pointer. We have given temporary pointer the value of b next. That will be the node we want to delete. Then we have given b next the value of temp next. That will be next pointer to the node we want to delete. And then we will delete our temp node. So basically our previous node get connected to our next node. So if we want to delete 2, let's try to visualize it. So here, firstly, we are getting to the previous pointer. Then, so here, we have to delete 2. So we are giving 4 next pointer the value direct to 3. And then we are deleting 2. And that's how we delete a node. And that's how we delete a node from the linked list. If we want to remove a node from the head, what we have to do is we have to just create a temporary pointer, give it the value head, give head the value head.next, and then delete the temporary pointer. We can we have taken the head and called it temporary. We have given the head value to head.next. Then we have just deleted the temporary pointer. And that's how we remove a head. So how will we delete the tail node? So firstly, we set up two pointers. One is pre and one is temporary. The pre pointer will always be previous to the temporary pointer. So here our previous pointer is at 4 and temporary pointer is at 3. So we have to find the node whose dot next is equal to null, so that it is pointing towards null. That means it is the end of the linked list. So 3 dot next node is not pointing towards null, it is pointing towards 7. So we move forward. Now 7 dot next is pointing towards null. That means that is end of the list. So what we do is we set next of pre pointer to null. And now this is our linked list 4 and 3, because we have lost the address to the next node, so it is actually gone. So now we have created node, then we have created a list, we have displayed it, we have deleted its node. So now what more can we do? We can search any element. So let's write function for searching. So now we have write the search function. We are inputting the value we want to search for. We are making a temporary pointer and giving it head. We are as the head is the starting of the list, so we are calling it the index 0. Then we are iterating over the list and saying if our data is not equal to v, then increase the index and go to the next node. And if it becomes to null, it means it comes to the end of the list, then return not found, else return index. So let's try to visualize it. So let's search 3 in this list. We firstly go to the head, it is not 3, we go to the next, then next, and then it is 3, so we got the answer. Let's search for 6. So for 6 we come to the head, then next, then next, and then next, and as there is no next node, so we return not found. So we have done many things related to linked list. We have deleted the node by inputting the previous node. We can input different things to make different operations. Like we can also input the node we want to delete and then delete that node. For that I have another video you can check out in the description box or in the cards above. So we have seen all the major operations that are done on a linked list, like adding the node, removing the node, searching for a node. So let's analyze its operations. So as we can't access the random elements, so the access or the search will take O and time. As to go to the ith position, we have to go all the way from head node to the ith position, and that will take order of on an average, where n is the length of the linked list. Adding a node either it is in front, middle or in the end, it will take fixed time, so it is a O1 operation. Deleting a given node from the front or the head will take a fixed time, but if we are deleting a node from the middle, we have to first go and search for that node and then have to delete it, so it will take order of O(n) time. So comparing it with array, so we can conclude that if we want to frequently add or delete the nodes from the list while maintaining its order, then linked list could be a better choice. Whereas if you need to access the element by its index often, then array might be a better choice. So I hope your concepts are little much clear now. If you like this video, give it a thumbs up. Thanks for watching, and I will see you guys in the next one.